Yes. So we will start the today second unit, that is unit 2, that is AC circuit. So in AC circuit, first as first unit, first we have the basic definitions. First we have the basic definition. What are those definitions? So what is it mean by cycle? What is it mean by uh, time periods? Right? What is frequency? Then what is the mean peak value? What is the maximum value? Then instantaneous value, then RMS value, average value. Then after that, form factor, peak factor. These are the definitions, right? So what is the instantaneous value? Instantaneous value, either it is voltage or current. This is important. If it is current, right, instantaneous value we denoted with small values, small letter. If it is current, instantaneous value, that is denoted with, if it is current, small letter, small I, that is Im sin omega t. Im sin omega t. Here Im is the maximum value. Im is the, here it is maximum value of the current. Right? Omega is equal to, what is that? 2 pi f. Omega is equal to 2 pi f. Right? If it is same the instantaneous value, if it is voltage, we denoted with small e or small v, right? E or v, that is Vm sin omega t. Right? Here Vm is the maximum value of voltage, omega is equal same thing. This is the instantaneous value. Then RMS value, we have the RMS value. RMS value, what is that? What is that? RMS value. మనం డెరివేషన్ చేశాము అప్పుడు, దట్ ఈజ్ 1/√2 క్యాలిక్యులేట్ చేయండి వాల్యూ. Hmm?
0.707.
Yes. So that is 0.707 into whatever that maximum value, or we can call it is Em/√2. If it is voltage, right? RMS value of the voltage. If it is current, that is same thing, 0.707 into Im, or that is Im by root 2. This is the RMS value, right? Then next to average value, form factor, peak factor, all those things we did. So these are the basic definition parts. We have to know that clearly, these definitions. Yeah. So then here in the second unit, we have to know that the very fundamental concept, those are three words: in phase, lagging, and leading. What is in phase, what is lagging, and what is leading? So in phase means it is very simple. So once again I am explaining. So here, if the two alternating quantities reach their maximum and minimum values at the same time of interval. If the two alternating quantity reaching their maximum and minimum value at the same time of interval, then those two alternating quantities are in phase to each other. So here I am taking two alternating quantities. Here alternating means which alternates between the positive cycle and negative cycle. What does it mean by cycle? What does it mean by cycle? What does it mean by cycle?
One crust and one trough, sir.
Huh? What is that?
One complete set of positive and negative values of alternating quantity.
One complete set of one complete set
Positive
of
and negative values of
one complete set
positive and
of
negative
positive
values
and
of
negative
alternate.
values is known as cycle, right? So here, yeah. So yes. Then here I am drawing. Okay. So here I'm taking one voltage. Right. This is one alternating quantity. Okay. So this is V or current I, that is I is equal to Im sine omega t. Because of it started from 0, here it is pi, here it is 2 pi. Then another alternate quantity, that is, see, the magnitude may be difference, but this is also reaching their maximum and minimum values at the same time of interval, right? Yeah, here it is just, it is I1 or I2. Those may be two alternating quantity, those may be voltage, or those may be current, or it is combination of voltage and current, or it is it must be alternating quantity, right? So that here I2 is equal to Im sine omega t, right? This is one alternating quantity, here it is another alternating quantity. So here, so those two alternating quantity reach maximum. So here in this alternating quantity, here it is maximum value, right? Here it is I1 max, here it is I2 max. Both are reaching their maximum value at the same time of interval, that is, here assume it is pi by 2, right? And those are reaching minimum values at the same time of interval. Then here these two quantities are in phase to each other. So this is the in phase definition. So in phase means the vector diagram, we can show that here it is the, so initially I am I1 consider as a reference. Then here what is the I2? I2 is in phase means I2 quantity, I2 alternating quantity is following the I1. So here we are drawing I2, right? So here point should be remembered here. I1, I2 both are in phase. Then what is the angle here? First point. What is the angle between these two quantity? It is
0.
0 degrees, right? If it is 0 degrees, then power factor, power factor, power
Cos
factor, that
0.
is
1, sir.
cos phi, right? Then cos 0 is how much? 1, right? Then power consumed power, third point. In AC, power is equal to, what is that standard formula? V into I into cos phi. Right? Here cos pi is equal to 1. Then here that is P is equal to V into I. Here V, if it is not mentioned, either it is average, RMS, or instantaneous, either mention cheyakapote, assume that it is RMS only. So this is the thing happen in that instantaneous quantities, right? So here it is, sorry, not instantaneous, it is what we call it is in phase, it is in phase, right? So here phase difference, next one is the phase difference. That phase difference is nothing but here, yeah, So just observe here, and I will draw the two diagrams. Then here it is, yeah, here it is voltage V is equal to Vm sine omega t. Then coming to here it is, this is current. I is equal to Im sine. So here voltage is started at 0, right? Then current is not started at 0. Current eppudu start avutundi ikkada? Current is started after the voltage, right? After the voltage started. So here it is, angle is pi. Then sine omega t minus pi. It means current is started after the starting the voltage. So here current is lagging by some angle. That angle may be that angle is depends on that the power factor, right? So here this is the lagging circuit. Here I am taking voltage as a reference, then current lagging, right? So next level diagram. So here I'm considering voltage as a reference, that is V is equal to Vm sine omega t. Then here current. What is the current here? I is equal to, current is started before the voltage. You got my point? Here current is started before the voltage. That is how much angle here? Pi. Right? So current equation ఎలా రాసుకోవచ్చు చెప్పండి? How to write down the current equation? I am sine. Can you tell me that?
Omega t plus pi.
Omega t plus pi. So here current is leading, right? Current is started before the voltage. So that's why it is a leading circuit. Here always which quantity we are considering as a reference, that's important, right? Suppose in this quantity here, yeah, suppose here if you are considering current as a reference, okay, student, current as a reference, I am writing that I am sine omega t. Then what is the voltage here? If current as a reference, voltage ఎలా రాసుకోవచ్చు చెప్పండి? That is Vm sine omega t plus pi, right? When we are comparing, so here it is always which quantity we are considering as a reference and which quantity we are comparing, right? That is the equation here. So you got my point. What is the in phase, what is the lagging, what is the leading? Is this clear?
Yes, sir.
Right. So here, so according to this, so in pure resistor, pure inductor, pure capacitor, what is happening here? When I am considering, I am not deriving the equation, just overview. In AC through pure resistor, pure R. In pure R, what is happening here? Both V and I are in phase. Both
Sir,
are in phase. Yes.
sir, one doubt, sir.
Ah,
Sir,
yeah.
like in the above graph, if like voltage is starting first, no, sir.
ఎక్కడ
So with
ఎక్కడ ఏ గ్రాఫ్ లో లాగింగ్
first
లోనా
graph,
లాగింగ్
lag,
అని రాసి హియరా
lag. Yes, sir. Sir,
హియర్
like initially voltage started, no, sir. So with reference to I, V is leading, sir.
Yeah, see, just observe the waveform. Here voltage is started 0, but generally we will consider the reference when which quantity started from 0. But నేను ఇంకా next advanced stage లో if I am considering current as a reference, if I am considering current as a reference, right? When I am considering current as a reference, then here voltage is started before the current. Voltage is started before the current. So that's why here voltage is leading. If you are considering current as a reference, then voltage is leading. You got my point?
Yes, sir.
This is clear?
Yes, sir. Thank you.
Okay.
సార్ ఎప్పుడు కరెంట్ నే రెఫరెన్స్ లెక్క తీసుకుంటాను.
అట్లేమీ లేదు. See, generally which quantity is started from 0 degrees, right? దాన్ని మనం రెఫరెన్స్ గా తీసుకుంటాం. ఓకేనా?
ఓకే సార్.
Yeah. So yes. So in pure resistor, both voltage and current both are in phase. We derived that equation. ఏమొస్తుంది మనకి ఈక్వేషన్ ఇక్కడ డిరైవ్ చేసినప్పుడు మనం వోల్టేజ్ ని రెఫరెన్స్ తీసుకుంటే వోల్టేజ్ ని రెఫరెన్స్ తీసుకొని దట్ ఈస్ వాట్ ఈస్ voltage E is equal to Em sin omega t. Then current is also, we got that equation, I is equal to Im sin omega t. Here these are the two equations. So by comparing these two equations, both are in phase. Both are in phase, right? So here in phase means what is that? Here both are in phase means the angle, that pi is equal to how much? 0 degrees. So when the angle is 0 degrees, then cos pi is equal to cos 0, how much? 1.
1.
Then power is equal to, that is V into I into cos pi. So that is power is equal to, it is always V into I. It means V RMS and I RMS. This is the thing happen in that AC through pure resistor. AC through pure resistor. Then AC through pure inductor. Pure inductor. So what is the happening here in AC through pure inductor? Just I am considering the inductor. Here you are given AC supply. Then here we are given some supply. Then here current will, instantaneous current will flow. Then this inductor will stores the energy, that is whatever the consumed. Then here E should be equal to EL. Then according to that, E is equal to Em sin omega t, right? Then EL is equal to the voltage across that inductor, that is L into di by dt. L into, if both are equal, then Em sin omega t, that is L into di by dt is equal to Em sin omega t, right? ఫ్రమ్ దిస్ ఈక్వేషన్ మనం డెరివేషన్ చేసాం. ఈ డిటిని ఇటు తీసుకెళ్తే దెన్ డిఐ ఈజ్ ఈక్వల్ టు ఏమవుతుంది? డిఐ ఈజ్ ఈక్వల్ టు దట్ ఈస్ ఈఎం సైన్ ఒమేగా టీ dt, and here it is em by l. So after the derivation, here we get that I is equal to im sin omega t minus pi by 2. This is equation 2. Here it is equation 1. This is okay. మళ్ళీ ఈక్వేషన్ చేయాలా? ఇక్కడ ఆల్రెడీ మనం డెరివేషన్ చేశాం క్లాస్లో. ఓకేనా? So here, when compare these two equation, when I am considering voltage as a reference, Em sin omega t, here it is Em sin omega t, then current is here exactly lagging by pi by 2, 90 degrees. So here, the point to be remembered, the same, yeah. In pure inductor, current I lags to the voltage by an angle of pi by 2. By an angle of pi by 2. You got my point? So here, so the angle here, pi is equal to pi by 2. Then coming to the power factor. What is the power factor? Power factor cos
0.
pi is equal
Cos
to
90.
right, cos pi by 2. Cos pi by 2 is how much? How much?
0.
Very, very good. Excellent. So here, then coming to the standard formula, power is equal to, yeah, power is equal to, power P is equal to, what is the standard formula? VRMS IRMS into cos pi. Here, cos pi is equal to 0. Then 0 into current into voltage. What is that resultant value?
0.
0 into something. So here, pure inductor consumed power is 0 watts. So it means pure inductor does not consume any power. Right? This is the thing happen in that. So vector diagram ఎలా డ్రా చేయొచ్చు ఇక్కడ మనము? If I am considering voltage as a reference, that is voltage E, then here current is lags to the voltage. How much? By an angle of pi by 2. Right? All these things we derived that. Do you remember? గుర్తుందా ఏమన్నా? గుర్తుందా?
Yes, sir.
Number 42.
Yes, sir.
గుర్తుందా తల్లి ఏమన్నా?
సార్ కొంచెం ఇప్పుడు చూసుకుంటే నాకు గుర్తొస్తుంది.
అప్పుడు ఎప్పుడో చూసినట్టుందా? Please recollect all those memories before corona, after corona. Yeah. So then next one is the pure capacitor. Yes. So in pure capacitor, what is happening? A derivation చూసుకోండి, main points చెప్తాను. So here also, if you are giving supply voltage to the capacitor, E is equal to Em sin omega t. Here capacitor, then current will flows, then capacitor will get charge, right? Charge is equal to Q is equal to C into E, right? C into V. C is the capacitance value of the capacitor, E is the voltage. Then Yeah, then I is equal to dq by dt, right? Then if you derive that equation, that is C E is equal to what is that? Here I is equal to C into E, that is C into Em sine omega t, because of E is equal to here Em sine omega t. Then Q is equal to what is that? C into Em sine omega t. If I derive this equation, here we will get that I is equal to Im sine omega t plus pi by 2. This is equation 2. Here it is equation 1. If you compare these two equation, when I am considering voltage as a reference, that is E. What is the current here? What is the current here? Im sine
Leading.
omega t. How can you say that it is leading? How
Plus.
can you say that it is leading? Here,
Plus
yeah.
pi by
This,
2.
this sign.
Plus pi by
This plus sign indicating it is leading, right? How much that leading? It is pi by 2. How much angle? That is pi by 2, right? So here it is the current I, angle is pi by 2, right? This is the thing, how things happens in that. So only here the previous pure inductor and pure capacitor difference ఏంటంటే pure inductor లో current is lagging, here it is leading. Then angle between the voltage and current here, what is the angle between the voltage and current here? Pi is
Pi by
equal to pi by 2. Then cos pi, power factor again same, cos pi by 2. Then cos pi by 2 is how much?
0.
Very good, excellent. Then power is equal to P, same thing, that is V
Yeah,
into cos pi, right? Here I am not mentioning RMS or RMS. Then assume that it is RMS. If it is not mentioned, assume that it is RMS. So what is the power consumption here? 0, right? So pure inductor and pure capacitor does not consume any power, right? So then next, after that, if you know the individual topic easily, individual topic thoroughly, then we can understood the combination of resistor and inductor, that is R and L, AC and R and L, then R and C, then
Sir,
R L C. Yes.
sir, one
uh
one show the pure capacitor equation, sir.
what is that?
One show the above topic, sir. Pure capacitor.
Pure capacitor, so scroll down cheyala.
Yes, sir.
Okay.
Thank you, sir.
Sir,
Oh,
so this RLC, RC and RLC, I mean, all are this in series, no, sir? If they ask
yeah,
parallel RLC circuits, means we need to make in parallel connection, sir.
yeah, parallel is also same thing. If you know the basic series parallel combination, it is very easy. See, okay, here in parallel, క్లాస్ ఉంది, తర్వాత ఇసాల్పోతుంది. మమ్మీని పిలుపు. Yeah, so here
Sir, how to draw phasor diagrams if they are in parallel?
yeah, according to that angle we have to draw the phasor diagram, either it is parallel or series, we will get some angle now. So here in parallel and series, okay, I will tell. So here we are all, these are the series circuit. Here all these are the series circuit. So here in series circuit, so here the point is in RL circuit, the Z is equal, first here in RLC circuit, Z is equal to, what is that? R plus J XL minus XC. R plus J XL minus XC. If you want to get the magnitude, that is Z is equal to under root of R square plus XL minus XC whole square, right? So this is the, here we will get that magnitude. Here we will get that magnitude. And here this is J form, J notation. So either it is in polar or rectangular?
Rectangular.
It is rectangular. Right. Polar to rectangle, rectangular to polar conversion gurtunda?
Yes, sir.
Sure.
If anybody have the doubt, ఇప్పుడే clarify చేసుకోండి. క్యాల్సియం అసలు ఈ రోజుల్లో ముట్టుకున్నట్టు లేదు అసలు. Anybody have the doubt?
No, sir.
Okay. P naught.
Yes, sir.
Calculations polar to rectangle, rectangular to polar వచ్చా?
వచ్చు, sir. Yes, sir.
Okay.
Yes, sir.
Okay. Rule number 18. 18.
Yes, sir.
718. వచ్చా నాన్న క్యాలిక్యులేషన్స్?
సార్ ఒకసారి చూసుకోవాలి సార్.
ఇంకెప్పుడు చూసుకుంటావురా మరి?
ఇవాళ చూసుకోవాలి.
ఇప్పుడు నేను అది అడుగుతున్నా కదా, అడుగుతున్నప్పుడు అది క్లారిఫై చేసుకో. ఇప్పుడు
చెప్పండి సార్.
ఇట్లా గుచ్చి బొట్టు పెట్టి మరి అడిగితే ఆ తర్వాత చెప్పండి. క్యాల్సి ఉందా చేతిలో?
Yes, sir.
షోమీట్ చూపించు నాన్న. వెంకటరమణ, సుప్రభాత్, ఒకసారి చూపించు. కమ్ ఆన్ టు ద స్క్రీన్. టర్న్ ఆన్ యువర్ కెమెరా. యా, ఓకే. సో ఒక వాల్యూ తీసుకుందాం ఇక్కడ. Z is equal to some 10 plus J XL minus XC, డైరెక్ట్ వాల్యూ తీసుకుందాం, సమ్ 15, రైట్? సో దీన్ని కన్వర్ట్ చేయాలి నేను. ఇది ఏ ఫామ్ లో ఉంది? రెక్టాంగులర్. ఎస్. సో క్యాల్సీలో యా షిఫ్ట్, నాకు ఎవరైనా స్క్రీన్ ఆన్ చేయండి. క్యాల్సీలో అవి కూడా మర్చిపోయాను నేను. షిఫ్ట్ బటన్ ప్రెస్ చేసి ప్లస్ మైనస్ ఒకసారి ఎవరైనా క్యాల్సీ ఆన్ చేయండి. వెంకటరమణ ఆన్ చేయి.
Shift plus.
యా,
Shift minus.
Shift plus, sir.
యా, షిఫ్ట్ బటన్ ప్రెస్ చేసి ప్లస్ బటన్ ప్రెస్ చేయండి. షిఫ్ట్ ప్లస్, దెన్ పుట్ దట్ వాల్యూ 10 ప్రెస్ చేయండి. దెన్ ఆఫ్టర్ దట్ అగైన్ షిఫ్ట్ బ్రాకెట్ క్లోజ్. ఐ రైట్? బ్రాకెట్ క్లోజ్ చేస్తే కామా బటన్ వస్తుంది.
Yes, sir.
యా, దెన్ again press the normal value 15. దెన్ ఇప్పుడు నార్మల్ గా బ్రాకెట్ క్లోజ్ చేయండి. నార్మల్ గా బ్రాకెట్ క్లోజ్ చేసి ఈజ్ ఈక్వల్ టు కొట్టండి. దెన్ యూ విల్ గెట్ సమ్ వాల్యూస్. వాట్ ఈస్ దట్ వాల్యూ? ఏమొచ్చింది చెప్పండి. చేశారు ఎవరన్నా?
R equals to 18.027. Theta equals to
18.027. Yeah.
Theta equals to 56.309.
6.30. So here, this is which form? Here, this is the polar form. right? So here the point is, if you use rectangular and polar, here in this formula, you will get only magnitude. But here, see, same thing, ikkada z is equal to ila cheyandi. Z is equal to, what is that, under root of 10 square plus 15 square. Do it now. 10 square plus 15 square.
18.02.
18.02, sir.
18.02.
So here we will get only magnitude. Chudandi ikkada, the magnitude. But here we will get magnitude and angle also. Magnitude and angle also. So this polar to rectangle, rectangular to polar, we have to use if you want to draw the phasor diagram. So ఇప్పుడు ఇక్కడ yeah, yes, z ki, okay, and here is the same simple problem అనుకుంటే v is equal to some 200, right? 200 volts ఇచ్చారు అనుకోండి. సో ఇట్ మీన్స్, సో ఇక్కడ v కి z కి వెక్టర్ డయాగ్రామ్ లేకపోతే v కి కరెంట్, దెన్ కరెంట్ I is equal to, what is the formula? I is equal to
V by Z.
V by Z. Then V is equal to here 200 angle of 0, because of here it is just given 200. So if it is just angle ఇవ్వలేదు అనుకోండి, assume that it is 0 degrees reference. Then Z is equal to, what is that here? 18.027 angle of 56.30, right? So here, then yeah, then ఇక్కడ మీకు ప్లస్ ఆర్ మైనస్ ఇది చెప్పాను, ప్లస్ ఆర్ మైనస్, right? We should go to the rectangular form, and multiplication or division, it should be polar form. It should be polar form. So here it is polar form. Then magnitude 200 divided by 18.027. 200 divided by 18. So what is that? How much?
11.0.
11.0.
11.11.
11.09.
Okay. And angle should not divided. Numerator minus denominator, right? So 0 minus of 56.36. How much? Minus 56.30. So here, by observing this voltage and this current, here this is the current value, then we can draw the vector diagram. See, here I am drawing the vector diagram. Z ni also, Z కూడా తీసుకుందాం. ఇక్కడ ఇప్పుడు voltage V is equal to here 200 angle of 0. Then what is the current here? How much current we got? 11.09 angle of this, angle of 50 minus 56.30. This minus sign indicating what is that?
Lagging. Negative.
It is a, this minus sign indicating it is a lagging. So here it is the current I. Current I. How much it is? 11.09 angle of minus 56.30. Then here, when I am putting that angle, here ikkada minus pettodu 56.30. That minus sign indicating here, minus sign indicating it is a lagging, but angle అనేది minus లో ఉండదు. You got my point? Then Z is equal to, we got the Z. Z is equal to, what is that? Z is equal to how much? 18.027 angle of 56.30. Then this is, here it is Z. How much it is? 18.027 What is the angle here? 56.30. You got my point?
Yes, sir.
Okay, now. So this is the voltage, current, and Z. Yeah. Yes. So coming to the point here. So in RLC circuit, in RLC circuit, Z is equal to, so that is R plus J XL minus XC, right? Then if it is only RL circuit, so only RL circuit means in that circuit we don't have the XC. Am I clear? So in the standard Z equation, R plus J XL minus XC in RL circuit means we don't have the XC, capacitor is not there. Then can I draw the circuit here, RLC circuit? One second guys, clear ga meeku chinna difference తీసుకుందాం. RLC circuit. So here resistor is there, inductor is there, and capacitor is also there. Here resistor, inductor, and capacitor. Here I am given supply voltage. Then here current I. So here, what is the Z is equal to? That is R plus J XL minus XC. XL is equal to what is that? Omega L, and it is 2 pi FL. Then XC is equal to, what is the XC? 1 by omega C. Not omega C. Chala mandi chese mistake ade. So that is 1 by 2 pi FC. This is happens in that RLC circuit. Then suppose if it is RL circuit, RL, resistor and inductor. Then resistor and inductor. Then here we don't have the capacitor. Here R and L. Then what is the Z here? What is the Z here? Z is equal to, can you tell me what is the Z? R plus
J.
J into XL.
Because here XC, capacitor, is not there. So that's why Z is equal R plus J XL only. Then what is the XL? Same thing. XL is equal to omega L, and it is 2 pi FL. Then I is equal to what is the formula? Same, V by Z. Here also I is equal to same thing. That is V by Z. Right? This is the RL circuit. Then RC circuit. That is RC circuit. So here we have the resistor and capacitor. Then RC. Then voltage. Then can you tell me what is the Z here? Z. What is the Z?
R minus minus J into XC.
R minus J XC. Because of the nature of inductor, it is a plus. Here capacitor is the minus. Right? Then to get that magnitude here, for this quantity magnitude, Z is equal to under root of
R
R square plus XC square only. Right? Then here also I is equal to V by Z. Then XC is equal to here 1 by omega C, and that is 1 by 2 pi FC. This is the RC, RL. These are the series circuit. Then if it is parallel circuit lo kuda same concept. Suppose here just I am taking one problem తీసుకుందాం parallel circuit ki. Here resistor is
Sir.
there, inductor.
Sir,
Yes.
like, what is the relation between XC and XL, sir? XC and XL relation, sir.
The relation ante em relation?
Like, is there any formula if XL is given to find XC?
No. Those are to calculate the XL and XC. We have the means only the formula is 1 by omega C. It is 1 by 2 pi FC. We derived that pure inductor, pure capacitor lo మనం derive చేశాం. XL, XC మనకు ఎలా వచ్చింది అన్నది. ప్యూర్ ఇండక్టర్, ప్యూర్ కెపాసిటర్ నోట్స్ తీయండి, అక్కడ డెరివేషన్ చేశాం. XL, XC ఎలా రాశాం అన్నది. ఓకేనా?
Yes, sir.
Both are these two XL and XC. These are the imaginary quantity, right, on the y axis, right? ఇండక్టర్ అన్నది పాజిటివ్ లో ఉంటుంది, కెపాసిటర్ అనేది నెగిటివ్ క్వాడ్రేచర్ లో ఉంటుంది కాబట్టి మైనస్ తీసుకుంటాం. బోత్ ఆర్ ఇమాజినరీ యాక్సిస్. సో హియర్ then resistor and capacitor, this is connected to the supply voltage. Okay, so here resistor some 20 ohms, right? Here here inductor value is some 50 millihenries. Then here resistor is some 30 ohms. Then here some 100 microfarads. Then here supply voltage 200 volts, 50 hertz supply. Then current I calculate cheyali, right? I is equal to, what is that general standard formula? If it is DC, I is equal to V by R. If it is AC, I is equal to V by Z. So remember this point. Then Z, total Z calculate cheyali ikkada. Z is equal to here, see here resistor 20 ohms, assume that it is R1, here it is R2, here it is L, here it is C. So R1 and L, it is a one branch. R2 and C, this is another branch. So here it is Z1, here it is Z2. Then what is the combination of Z1 and Z2?
Parallel.
So to calculate the equivalent Z, first we have to calculate the Z1, right? Z1 is equal to, what is that formula? R1 plus J XL, right? R1 value is given. How much R1 value? R1 value is 20 plus J XL. XL we have to calculate. What is the XL? How to calculate the XL? That is 2 pi.
2 pi XL.
That is 2 into pi into F is equal to how much? 50. L is equal to 50 into 10 to the power minus 3. Guys, మీకు నెక్స్ట్ క్లాస్ ఎప్పుడు?
10:25.
కంటిన్యూ చేద్దామా లేకపోతే
బ్రేక్ సార్?
Continue.
వాట్ ఐఎమ్ ఆస్కింగ్,
కంటిన్యూ సార్.
ఈ ప్రాబ్లం కొంచెం ఫ్లోలో ఉన్నాం కదా, కంటిన్యూ చేద్దామా?
కంటిన్యూ సార్.
నేను కావాలంటే ఆ సార్ చెప్తాను. నెక్స్ట్ క్లాస్ ఏంటి, మ్యాథ్సా?
ఎస్ సార్.
మ్యాథ్సా? నేను మ్యాథ్స్ అంతా పర్ఫెక్ట్ కదా. మ్యాథ్స్ లో జెమ్స్ కదా మీరు.
అరే నమ్మ ఫస్ట్ ప్రాబ్లం చెప్పరా బాబు.
మిస్టర్ నితిన్ రెడ్డి చెప్తారా బాబు? చెప్తా, ప్రాబ్లం చెప్దామని చెప్తున్నా. మిస్టర్ నితిన్ రెడ్డి, రూల్ నంబర్ 50 మళ్ళీ మర్చిపోతా. ఎస్ 20 ప్లస్ జే ఎక్స్ఎల్ క్యాలిక్యులేట్ చేయండి. ఇది 2 పై ఎఫ్ఎల్
5 pi.
2 పై
5 pi.
హౌ మచ్ ఎక్స్ఎల్ వాల్యూ?
5 pi, sir.
5 పైన వాల్యూ చెప్పండి అంటే ఏం చెప్తున్నారమ్మా? వాట్ ఈస్ ద ఎక్స్ఎల్ వాల్యూ?
15.7. 15.7, sir.
15.7. So that is 15.7. So this is the R plus JXL. So ఇక్కడ నాకు యాంగిల్ కావాలి. Then convert it. That is Z1. Then Z2 is equal to that is R2 minus JXC. That is R2 is equal to 30 minus JXC. XC is equal to, what is that XC? 1 by omega C. That is 1 by 2 pi FC. That is XC is equal to 1 by 2 into pi into F is equal to 50 into C is equal to 100 microfarads, 10 to the power minus 6. This is XC value. Calculate it.
Zero 0314.
How much?
0.0314.
Calculate it properly. Twenty plus J.
Sir, 31.84, sir.
31.84.
Yes, sir, 31.
So that is 31.84. Then here it is Z2 30 minus J 31.84. This is which form? Rectangle. Right? ఇక్కడ పోలార్ ఫామ్ లోకి కన్వర్ట్ చేయండి. ఇక్కడ కన్వర్ట్ చేసి పెట్టుకోండి. పోలార్ ఫామ్ లోకి కన్వర్ట్ చేసి చెప్పండి నాకు ఇక్కడ వాల్యూస్.
Z1 R equal to 25.42.
What is that?
R equal to 25.42. Theta equal to 38.13.
38.13. Z2
R equal to 43.7.
43.7.
Theta equal to 46.704.
So these are the Z1, Z2 values. Then after that, so Z equivalent is equal to, what is that? Same like as in the resistor we are doing series parallel. So Z equivalent is equal, here Z1 and Z2 both are connected in parallel. So in parallel, what is the equivalent impedance? That is Z1 into Z2 by Z1 plus Z2. Right. So here either it is parallel series circuit or series circuit, the basic fundamental concept is same, but in parallel we require some additional calculation. So ఇక్కడ న్యూమరేటర్ లో Z1 into Z2 ఉంది. ఏం చేస్తున్నా నేను ఇక్కడ మల్టిప్లై చేస్తున్నా. సో when it is multiply, it should be in which form? It should be in which form? Polar form.
Polar form.
So that is 25.42 angle of 38.13 into 43.7 angle of 46.70. Then coming to the denominator, Z1 plus, ఇక్కడ మల్టిప్లై చేస్తున్నాం, ఇక్కడ ప్లస్ చేస్తున్నాం. సో ఏ ఫామ్ లో ఉండాలి? పోలార్ డినామినేటర్ లో ఏ ఫామ్ లో ఉండాలి? ప్లస్ చేస్తున్నాం కాబట్టి రెక్టాంగులర్ ఫామ్. సో దట్ ఈస్ 20 plus j 15.7 plus 30 minus j 31.84, right? Z equivalent. So ikkada yeah, in numerator magnitude multiply with magnitude, 25.42 into 43.7. Do it now.
111
Yeah, 111 angle, both add చేయండి. 38.13 plus 46.70. How much?
84.83.
Then denominator 20 plus 30, 50. Then plus 15.7 minus 31.84. So minus 31.84 plus minus 31.84 plus 15.7. How much?
16.14.
Minus 16.14.
Minus 16.14.
Then again, now magnitude divide. So here in numerator we have the in polar form, in denominator we have the rectangular form. So ఇక్కడ నేను డివైడ్ చేస్తున్నా కాబట్టి again you have to do that 111 0.8 84.83. then denominator ని మళ్ళీ కన్వర్ట్ చేయండి. It is in rectangular form, now convert in polar form. Convert it in polar form.
R equals to 52.54
54 angle
minus 17.
Minus
angle minus
Minus 17.89.
17.
right. So again 52.54 angle minus 17.8. Then now divide it. Right, division, that is finally Z is equal to, then Z also some whatever that, do that. Then after that I is equal to, what is that? V by Z. We know that 200 angle of 0 ikkada Z also. So according to that we have to here just only the calculation. So in every quantity we know that the angle, right? Then we can draw the diagram, vector diagram according to that. Am I clear?
Yes, sir.
Yes, sir.
ఓకే, ఒక్క 2 minutes వెయిట్ చేయండి అన్న, అటెండెన్స్ తీసుకుంటా. ఓకేనా?
Sir, like why we need to convert into polar, sir, again?
Because of ikkadna in this point, in this point,
Yes, sir.
Yes, sir.
because of here we are doing division. Here numerator division ikkada 111 divided by some quantity. If it is dividing, so ade cheppanu ippudu ikkada plus or minus, it should be which form? Rectangle, right? then multiply or division, it should be polar form లోనే ఉండాలి. ఈ ఫామ్ లో ఉన్నప్పుడే మనం ఆ క్యాలిక్యులేషన్ చేయాలి. This is in which form? Here it is in which form? Polar. Here it is rectangle. Right? So if it is polar and rectangular, we cannot divide. Right? Then convert into this rectangular form into polar form. Then here we are getting polar. Then this polar I am putting here, and we are, so now here it is both are polar form, here also it is polar form. Then we can divide. Okay na? D section CR.
Sir,
Charini, yes. Yes, Sirisha, B3.
sir, one.
Huh?
Sir, I is equal to V by Z కదా సార్. అయితే V వాల్యూస్ మీరు 200 volts and 50 hertz ఇచ్చారు కదా సార్. అయితే మనం ఇప్పుడు V is equal to 200 plus 50 టోటల్ యాడ్ చేసి V by Z తీసుకోవాలా సార్?
ప్లస్ 50 ఎందుకు?
2 volts ఇచ్చారు కదా సార్ మీరు.
అది 2 volts కాదు, 50 hertz అంటే ఫ్రీక్వెన్సీ, అది వోల్టేజ్ కాదు. That's
Okay,
not
sir.
voltage. I'm giving some supply voltage. ఆ సప్లై వోల్టేజ్ లో నేను ఫ్రీక్వెన్సీ మెన్షన్ చేశా.
ఓకే సార్, HZ. ఓకే సార్, చూసుకో. థ్యాంక్ యూ సార్.
Yes, P3. CR madam.
Yes, sir.
Clarifying the doubt?
Sir, I have first, sir. Can I clarify that? Second chapter, sir. I have more doubts, sir, in second chapter.
Okay.
Can I? So first is, what is the difference, like when do we use this rectangular and polar form, sir? Because in the normal question also we can just find the magnitude, no, sir? Like
Here,
when do we actually use this?
Yeah, that. Here, suppose if you want to draw the vector diagram, without knowing the angle, how can you draw it?
Yes, sir.
Guys, ఒక్క 2 minutes వెయిట్ చేయండి, నేను అటెండెన్స్ తీసుకుంటాను. లేకపోతే డూ వన్ థింగ్, యూ కెన్ లీవ్, నేను అటెండెన్స్ మాకు ఎక్సెల్ షీట్ లో నుంచి తీసుకుంటాను లేండి. లేకపోతే ఒక్క 2 minutes, జస్ట్ 1 minute లో అయిపోతుంది. J7, J8, J9, K0, K1, K2, K3, K5, K6, K7, K8, K9, L0, L1, L2, L3, L4, L5, L6, L7, L8, L9, M1, M2, M3, M4, M5, M6, M7, M8, M9, M0, M1, M2, M3, M4, M5, M4, M5, M6, M7, M8, M9, P0, P1, P2, P3, P4, P5, P6, P7, P8, P9, P0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 30, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 60, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 92, 93, 94, 96, 97, 98, 90, 9, A0, A1, A2, A3, A4, A5, A6, A7, A8, A9, B0, B0, B1, B2, B3, B4, B5, B6, B7, B8, B8, B9, C0. Yes, guys, you can leave.
Thank you, sir.
Yeah.
Sir,
Thank you, sir.
డౌట్స్ ఉన్న వాళ్ళు వెయిట్ చేయండి కావాలంటే. యా P3 you can wait.
Yes, sir.
Sir, 709 present, sir.
709
Present, sir.
కాదని ఎవరు చెప్పారు?
అండ్ మీరు ఆబ్సెంట్ వేసారు అనిపించింది సార్. నా దగ్గర ఆపారు సార్ నా నెంబర్ దగ్గర.
అలా ఎలా అజ్యూమ్ చేసుకుందాం? ఓకే
సార్ థెవెనిన్ థీరం నార్టన్ థీరం సర్క్యూట్స్ ఇవ్వరు సార్ కొన్ని సర్క్యూట్ ప్రాబ్లమ్స్ ఇవ్వండి సార్.
టెక్స్ట్ బుక్స్ లో ఉంటాయి కదమ్మా.
Sir, one day we'll solve question papers, sir. In question papers, circuits we will solve, sir, one day.
ఓకే ప్రీవియస్ క్వశ్చన్ పేపర్ సాల్వ్ చేద్దామా?
Yes, sir, please.
ఓకే షూర్ we will do it.
ఓకే సార్.
ఎస్టర్డే నువ్వు పంపించిన దానికి నేను పంపించాను కదా రిప్లై.
Yes, sir. One more question also. Two circuits they asked, sir, from Thevenin's theorem and KVL and KCL, sir.
One second just. లేదు అవ్వలేదు ఇంకా. Yes. So here, yeah, dissections here.
Yes, sir.
Yeah. Are you able to see?
Yes, sir, we can.
So here, just apply the Kirchhoff's laws here. Just here we have the 3 loops. Then in those loops, just apply the Kirchhoff's laws. Different voltages, currents are there. Then easily we will get that.
So
Then here
power
in
is equal
Thevenin,
to P into I we need to do, sir. They are asking power now, so we need to do power is equal to voltage into current.
that's all.
At each source, we need to do power. We need to find power at each source now, sir, by using case
Yes.
KVL.
Yeah.
Okay, sir. Sir, in the next.
In the next
question.
problem, in the second problem, see, find the Thevenin's equivalent with respect to the terminals AB for the, just here we have to calculate the only RTH. Find the Thevenin's equivalent with respect to the terminals AB for the circuit from the following. So here we have to find out only RTH. Can we solve this problem here now? Solve cheddam ikkada?
Yes, sir.
See, here only one thing you have to do that. While calculating the RTH, what we have to do, if it is voltage source is there, remove it and make it short circuit. If it is current source is there, remove it and make it open circuit. So this 1.8 amps is the open and here 9 volts is the short circuit.
Yes, sir.
Okay?
Yes, sir. Yes, sir.
Then just do that. So నాకు చేసి నాకు పంపించు ఓకేనా?
Yes, sir. So Thevenin's equivalent అంటే only resistance we need to Thevenin's
Only just RTH. Just only RTH we have to calculate.
Sir, in one more question, they asked admittance, sir. Admittance means inverse of impedance, sir.
Yes, admittance means just, yeah, we denoted it is Y. It is, yeah, it is, what is that? 1 by Z, that is equal to Y.
Sir, they gave admittance and they gave frequency is equal to some 50, sir. So they asked what are the components present inside the RL circuit. So we need to find out the resistance and inductor. How do we find current and voltage?
Send me that problem.
Okay, sir.
ఇంకెవరికైనా డౌట్స్ ఉన్నాయా బాబు? దిస్ ఈజ్ నాట్ రెగ్యులర్ క్లాస్, రైట్? మీరు ఓపెన్ అప్ అవుతేనే మీకు గెట్ ఇన్ అవ్వగలుగుతారు.